No? Okay, great. um, this is the big picture of the infrastructure. Um, on the public subnet, we are putting the monitoring and the dashboard on each region. Um, and then you can put as many private subnets as you want. And we are, like I said at the beginning, putting some security groups on each group of servers. So they allow a specific security group to communicate each other. How it works, all the automation and scaling. As I said, I'm using a bash script in order to orchestrate all the creation. This is just an example. We are putting here the IP subnet that we want on let's say East region, the name of the region, the IP subnet for the second one, then of course needs to be different than the other. The other region, the action that we want to execute, and the let's say stack. Action could be create, update, or delete, and the stack we have separated in, let's say, VPC, monitoring, dashboard, application 1, application 2, whatever. So as you can see here with a switch, we are just creating VPC, putting some kind of variables that we need to define previous to the creation, and then we are calling to some AWS CLI commands. So this could be executed from any place. No need to be like inside of your subnet or have a Linux or Windows instance in Amazon. The good thing is that, as you can see here, we're using only one file that can be used to create both VPC, let's say, on different regions, and just passing different parameters to it. This is an example of CloudFormation. This is how VPCs, it's a resource, we call a resource in CloudFormation. A VPC has some properties, let's say, like the Cedar block. That's a variable that we are defining when we're passing this from the bash to the CloudFormation. And on the CloudFormation, you can define user data for the instances that you are creating. In this example, I'm just putting a command to make a NAT and just touching some specific file for doing the NAT. Well, as we have, I said, regions, different regions, we need to look at them in just one single view. So this picture tried to make an example of how distributed you can have all your systems, and looks like they are in the same place. The cloud monitoring architecture is basically putting on different VPC on different regions, and then we are updating our files, just uploading to a centralized location, let's say S3, for example. So we put in the Nagios servers a cron job. There is downloading and uploading data based on the information that it has on the configuration directories. For example, you can just modify one host group here, but I mean you're modifying here and will be replicated to all your Nagios instances that you have with this kind of architecture. This could be as heterogeneous as you want, because probably in this region you don't have a lot of services, but here you have a lot, so it doesn't matter. In fact, you can have many Nagios, or let's say Zynga or whatever, on this VPC based on your needs, and they are all going to be sharing the same services, contacts, scripts, or host groups. Tools that we're using for this is basically live status in order to put data back to Throok. If you know what it is, live status is just a broker. And the good thing is you can just send and receive comments with that. The other thing that we're using, it's a REST API. We installed that on the Nagios servers, and with that we can just create or delete the host that we're creating or deleting. The good thing are both open source, so you can just modify as you want. The other thing is iWatch. iWatch is a file change notification system. So what it does is you can configure a specific command once the file system that you are monitoring is being changed. So as I said before, we are putting a file in a S3. Then with a cron job, we are downloading our files to Nagios. And well, you need to reload Nagios. No, you don't. You just need to configure iWatch to see, let's say, user local Nagios etc. And every file that is modified there, iWatch will reload Nagios. Good thing is can watch directory recursively. So if you put just etc from the configuration, all things that you have below that directory and it's modified will reload Nagios. Could be used for other things. I just use for this. And also we are using WebInject in order to create some user cases in order to provide, let's say, real user interface to our test. WebInject, with WebInject, what you can do is create the test case file, and then you can have several cases for a specific thing. For example, let's log into an application, then click on a specific, go to a specific link, retrieve some kind of, let's say, OAuth, and then with that OAuth that we are getting, go and execute something on an API. So this is basically the integration that we're doing, putting an mClient broker, REST, all the plugins that it comes with Nagios, WebInject, and iWatch. mClient for output data, REST for adding and removing hosts, the WebInject for application monitoring, and iWatch for files changes. In Amazon Web Services, you have the CloudFormation. On CloudFormation, you can just add user data. User data could be for Linux and also for Windows. You can write some kind of PowerShell scripts. What we're doing is, whenever we have a host that is being added to our system, we're using a curl line, and we're sending a post call to Nagios through REST when the service is starting. And we send a delete action with curl tool when the instance is shutting down. Also, we put the host type. So basically with that, we are defining what kind of host we are adding to our system. And with user data, also you can install tools, let's say like SNMP or NRPE or wherever that you want. For example, on the Windows systems, we install NRPE. Well, NS client. And we configure SNMP, adding the right community name. We disable the firewall or things like that. This is like the addition of the host. What we're doing is adding to RC local this line there is in Bash, and sending a file that is being downloaded previously on the user data. We download a host monitor, let's say, common file for all our servers, and then we are passing the instance IP, the monitoring instance IP that we are using at that time, and then, well, calling the RESTless API. It's like JSON based, so what we do is we replace the host name and the community here in order to configure all our servers. For the delete, what we do is put a bash script on run level 0, and we execute like a delete, sending the host name that we replaced previously and to the monit instance IP. So every time the host is going down in a init0 command, we are removing our host from the monitoring system. So basically that's the idea. I mean, just having a monitoring system, when you adding nodes, you're seeing, and when you're removing nodes, there is node there. So for adding and removing host, the iWatch sync and Nagios, host file is uploaded or removed in a central repository. So when you're adding a node, the node is added to the Nagios and then uploaded to the central repository. For new services, it's like the same, just putting a new service on the S3 bucket, and then it's going to be shared across all your Nagios. And same thing for host groups or service groups. Basically, the host groups are a group of servers or hosts, and you can just define them on user data with the CloudFormation script, just replacing some variables. So every time that you create a node, you can put as many host groups as you want, creating parents or childs for it. And well, this is basically the idea. So you can define a host and add your host groups as you want. So this could be like a nice view. So we have, let's say, a Bastion servers or gateway servers, and you can see here 249. And also, as this is a Bastion, but it's a Linux server, so you have a 249 also here. And then we have, let's say, Hadoop servers or Apache web servers. As you can see, there are different amount of services for the nodes, because it depends if they are if they have another host groups with services associated with. This is how you can associate services on the host groups. Let's say that I want that all Linux servers can have SSH, but I don't want the Windows ones. So on the Windows, I will configure ping, and also for Linux servers. In this example, you have the Linux CPU only for Linux servers, and Linux memory also for Linux servers. The main map or big map could be like this. So you have your squares here are like the host groups, and these are the services associated with, and you have all these servers that belongs to this host group. But as you can see, let's say here, this node belongs to this host group and to this one. So this host will have all these services and also this one. Okay. With Throok, we are collecting our data and using the panorama view in two big monitors that we have, like, I don't know, like 60-inch, something like that. So we have two tabs. One is for production and one is for pre-production, and we are just rotating every 30 seconds. Here you can configure or filter, let's say, from different sites. So you can just have all services on pre-production, and you can filter only critical and, let's say, critical warning or unknown. So basically, you can see only problems here. Then you have the mind map with all the services and the host and where the problem is. And this is how we are filtering our results. And well, here you can see all your backends that you have configured and the status of each. Same thing for reporting. We are creating reporting for different managers and for different groups. We're sending them by email every some schedule that we have configured there. And we are putting a specific application here as a host groups in order to send only the information that they want. Well, this is the extended visualization of your Nagios. And here, this is how we are filtering, let's say, on different regions. I don't know if you can read, it's barely. Here we have one region, and here we have the other region. So we are putting both, and then we're filtering for this application in particular. This is some graphics of SLA reporting. As Sven showed yesterday, you can get an SLA overview. You can see a specific host, and you can get this by a public URL, or you can get it by in a PDF by mail. Okay. With the bash that I executed this morning was created two isolated networks on United States, because I choose those two regions, one on East in Virginia and West in North California. Each one with a public subnet and a NAT instance for outgoing traffic, an IPsec tunnel configured between zones to communicate securely and encrypted, two independent monitoring systems, one Nagios on each with the mclive status, and two dashboards also on the public subnet. And this is just one single view of both regions. Everything was scripted on the CloudFormation on the user data, so no need to do any manual work. And also the instances that were created were added automatically to the monitoring system. I will show you some code of this. Let's say, okay, let me check. I will go a little bit faster at the beginning. Okay, this is how we create the VPC. As I said, just basically using a single file for both, just defining what's our first region and what's the second one. Then with some bash replacing, we are just putting the IP that I want for the NAT. And delete is very simple. It's just an API call for delete. For the monitoring, we are using, we need to know the VPC ID because they are dependent for each one. We need to define which the public subnet that the instance is going to be there. The key name that we are going to use for login to those instances, and let's say the size of the machine. Instance host type is basically the host groups where I will put in this instance. This is how you call to the monitoring, how to create the monitoring on both sides. And then what I'm doing is just getting from AWS the Nagios URL. The same thing is with Throok. And here is the NAT, how we are creating the NAT and how we are attaching the NAT, the network interface to the NAT. And basically that's all on the bash. The VPC template, you need to define some parameters. Let's say like the what's going to be your NAT IP, the domain name, on the subnet where you're going to sit all these. Then you need to create your resources. Let's say what kind of DHCP options you're gonna have. You need to associate that to the VPC, then create a public subnet, ask for an elastic IP for communicate between regions. Then you're creating the network interface, the internet gateway, the public road, and well, all your security groups here for communicate between zones. The NAT VPN template, basically, I will not show the same thing than before, but this is where it starts the user data. You are creating a bash file that is going to be executed on the first time that the machine is booting. Just modifying some files here, reloading Amazon has some kind of weird things. So every time that the network interface is detached to an instance and attach it again, you need to reload the IPsec service. So basically what I put here is every time that I get an IFAP local, I'm reloading the IPsec service. And this is basically how to configure, in our case, the IPsec, just putting what is the IP of the, we call left side and right side. What is the elastic IP that we have on left and right. And then we are putting a VPN key that you can pass with through the bash script to this CloudFormation script. Then you just config IPsec on, service IPsec start, and that's it. Same thing with instance 2 that we are creating, and the attachment for the network interface and the association with the external IP. And that's all. For the monitoring, it's almost the same, just creating things specifically for Nagios. Installing all the packages that we need, creating some folders, getting some default files that we have on the S3, installing all the PNAG, Nagios 3.5, and compressing, configuring, making the install. Some plugins that we are using for, let's say, MongoDB, the REST laws, What else? All the scripts that we have on a libexec location, and then creating here you can see we create the cron tab line for syncing our file system with our centralized location. Installing the live status, configuring it, and just doing some restart here. And creating the same lines that I showed before for the addition of this node to itself. And that's basically the monitoring template. Dashboard template is the same, but with Truk, and we're also installing Nagios on the same machine and configured it. That's basically the cloud formation. Okay, live demo would be like, let's say this. Ouch. When this script finish, you get two files, monit out and dashboard out. I will show just the dashboard. So you have a Nagvis on east, a Truk on east, Nagvis on west, and Truk on west. Let's say, let me check the whole URL. Just 1 second. If you have questions, just shoot it. So this is what you get at the end. Hey, hello. And now I lost the URL. Great. Thank you. So you receive two URLs. Let's say this is east, because you have east one here. And you have your two Nagios configured automatically. And you have your services created by automatically also because of the host groups and services association. And basically, if I remove one of these, you will now see like two hosts only with 14 services attached to it. And this is the other Truk that we have on west. And with the backends are just this one, the Nagios, let's say 1, and the Nagios 2. As you can see here, the subnets are different, so they are sitting on different places. So, QAs. No. That was fast. Yes, for the scaling, we're using the auto scaling features that Amazon CLI provides. In this case, what I showed you was a big URL, but that is an ELB with an instance that is attached to that ELB. But if you kill that instance, it's going to be recreated automatically with the same user data. So you're not going to lose anything. So whenever the Nagios host is being created, it will download all your files from S3, including your latest backup that was like a minute ago.
I was thinking the same, like if you don't have a cloud or stuff, yeah, you could try.
If you're not in Amazon, it's fine, because what you can do is just create, let's say, an instance with some specific code on it, in a bash script. That's what I'm writing in the user data. You put in the same bash script on some rc.local, and then when the machine is booting, you're gonna have the same results.
I was also thinking of Puppet and stuff. So
Yep, we are working
yeah.
on migrate all of this to Puppet or
okay.
Chef.
Okay.
Yep.
Thanks.
Yeah, no problem. Okay.
It seems like you're monitoring what actually is running, but do you have any monitoring for what should be running? Because now if a machine is shut down accidentally, it will still be okay, right? Or do you
Well,
have some sort of monitoring for those
you
scenarios as
mean
well?
if,
Or
let's say, by mistake?
yeah, someone goes in and is going to shut down one machine and accidentally kills 4 of them or something. Then they would be removed from the monitoring and everything will be looking nice on your
Yes,
screen.
because
Right?
as we run with cloud scaling, you have like a min instances that should be running. So let's say you have an auto-scaling group in Amazon, and you put like 2 min instances on it. So if you kill one, another will be created automatically, and you will still have 2. So that's the idea of not worrying about your instances. You need to be worried about that your SLA is what you said that should be. Let's say 4 nines. If you kill whole instances in one region, no matter, because DNS failover will move your traffic to the other region until the, let's say, active one recover. Okay, I just put all this information in the GitHub, so you can download, play, and whatever. And I just translated this from Google, so I hope it's fine. So if you have any questions and you want me to help you to do something, just this is my email address, so you can contact me, free of charge, first session. Okay, thank you very much for being here.